video, I'm going to show you how to derive a physical equation using the base units of the physical quantities that are in that particular equation. The question here says, the resistive force F acting on a sphere depends on its radius r, speed v, intensity ρ of medium. Derive an equation for F in terms of ρ, v, and r. Now, I'm just going to solve this problem so that you get the concept of how to tackle such problems. So the resistive force is the one that is in terms of ρ, v, and r. This means that it's directly proportional to this. Mathematically speaking, when we introduce an equal sign, we put a constant. My constant is represented by k in this particular problem, ρ, v, r. Now I introduce unknowns as indices to the terms on the right, the ones that are in terms of the equation. Now x, I'm going to put x for ρ, y for v, z for r. I now introduce my base units. The base units for F, we know that from the equation F is equals to ma. We know that from this equation, my base units of F equal to kg meters per second squared, like that. Therefore, when I introduce my base units into this equation, it's going to be kg meters per second squared is equals to k is a constant, so it doesn't have units. The units for ρ, that's density. Density is given by mass over volume, so that's going to be kg over meter cubed, and this can be written as kg per meter cubed, like that. So I'm going to put it there, kg per meter cubed, and we have velocity, or this is raised to the power x, velocity, meters per second, raised to the power y, radius, meters, raised to the power z. Now I expand my brackets, I get, on the left hand side we didn't have any brackets, just bring down like that. On the right hand side, x goes there, and also there, using the laws of indices, y, it goes there, and there. Z, it also comes here. Now we know from the laws of indices that if the bases are the same, we then equate the indices. Here, the bases that are the same, we have kgs, so the index here is 1, that's x, therefore 1 is equals to x. We equate for m for the meters. On the left hand side, the index is 1 is equal to, on the right hand side we have negative 3x plus y plus c. Then we have equating the indices of s, that is the second. We have negative 2 on the left hand side. The right hand side we have negative y. So y is equal to 2. We have 1 being x being equal to 1, y being equal to 2. So we just substitute here in this equation. We get 1 is equal to minus 3x, that is 1, plus y. My y is 2, plus z. Now negative 3 plus 2, so I have 1 is equals to negative 3 plus 2, that is going to be 1 plus c, like that, right? Then the next step, I going to be negative 1, right? The next step, negative 1 comes there, becomes 1 plus 1 is equal to z. So my z is equal to 2. Z is equal to 2, like that. Now, and substitute this into my original equation. My original equation, here it is. F is equals to k, the constant, rho, and we say the value for x is 1, so this raised to power 1. V, the value of v of y, the index of v, is 2. Then we have our other, which is raised to z. The value of z is also 2. So this is the equation that we have derived. So you have to know how to find your base units in order to carry out such problems. This is the end of a video. Don't forget to like, subscribe, and comment.